Alrighty. So in our previous video, we just talked about dividing straight across and how that can kind of give you the result of keep, change, flip. Today, or this video, what we're going to do instead is use algebra to show why keep, change, flip is a valid result. So I'm going to keep the same problem as before. 7/9 divided by, I think it was 2/9, or 7/11 divided by 2/9, I believe. And now we're going to use algebra. And how we're going to do this? Well, algebra typically involves making use of variables. So I'm going to take our fraction expression here, this little division problem here, and set it equal to some number n, because ultimately a number divided by another number that is non-zero, of course 2/9 is not equal to 0, we'll talk about 0 another time, that's just going to be equal to some other number n. I don't have to know what it is, but I can just treat it like I do, just put n there. So if I do this, what I can do is, okay, 7/11 divided by 2/9 times 2/9. Well, what is that equal to? 7/11. Because if I divide it by 2/9 and then multiply by 2/9, that effectively cancels itself out, and I'm left with 7/11. So if I take this guy, I'm going to leave it as a little thumb note. If I were to take this expression here and multiply it by 2/9, I get 7/11 on its own. Now, why am I doing this? Well, just bear with me. A little side note here, if I were to multiply this left-hand expression by 2/9, I'm making it 2/9 of the size. However, on the right-hand side, n has not yet been changed. And this is a problem because, well, we're dealing with an equation. This equal sign here is an issue for us because it says what's on the left is equivalent to what's on the right. Well, we just made the left-hand side 2/9 the size, so in order to make this still remain true as an equation, we must also multiply it by 2/9. So now the right-hand side is likewise 2/9 the size. And so these are now equivalent once more. Well, on the left-hand side, we're now left with 7/11. And on the right-hand side, we're left with, well, I'm going to go ahead and rewrite this. I'm going to say, okay, n is the same thing as n divided by 1, because any number divided by 1 is equal to itself. And n divided by 1 times 2 divided by 9 is equal to 2 times that number divided by 9. Now, I'm doing this for a specific reason, just because sometimes it helps to rewrite a fraction in this way. Now, if I wanted to wind up at, okay, I'm going to say the end goal here. The end goal is to reach an expression that looks like this, because this would allow us to see that, okay, our initial expression, the dividing by fractions, I can keep, change, flip, and have the same answer as my result. All right, so this intermediate step is very nice because there's no longer a division with the fancy division symbol here. So I like it right now, but I do want to get n by itself once more. So what I'm going to do is, if I have 2 times some number and divide that by 9, if I were to multiply that number by 9, I'm essentially undoing the 9s here, just like I was undoing this division by multiplying by that same fraction. Well, this just leaves us with 7, or sorry, I'm going to just deal with the right-hand side, 2n. Now, if I want to get n by itself, well, I could, if I'm multiplying by 2, if I divided it by 2, then I would wind up just with n. So I'm going to go ahead and divide this by 2 as well, and you see we got cancel, cancel. And ultimately, we will just be left with n over here. That's very nice. We got back to what we wanted on the right-hand side. However, if you may notice, we then multiplied essentially by 9/2, or multiplied by 9 divided by 2. So our right-hand side is now 9/2 the size of what it was in the beginning of the step, whereas the left-hand side has not changed. So to compensate for this, let's go ahead and multiply by 9 and divide by 2 as well on this side. And well, hey, now we have n equals this expression. And since, for instance, 3 times 5 equals 15 equals 5 times 3, it doesn't matter which way you multiply in mathematics. We say multiplication is commutative. So we can essentially just flip the order of these fractions, and hey, look at that. We got our end result. So this is a way to also see that keep, change, flip is legitimate using algebra skills. Hopefully you see why algebra is very useful in this sense. And yeah.